All right, welcome everybody. Today we're going to be talking about section 12.4 and something that we call expected value. So expected value is used to determine the expected results of an experiment or a business venture over the long run. So it takes into account all of the probabilities, and then over the long run you can determine what will come out of all of these probabilities. Now, expected value is found by multiplying the probabilities of each event by the net amount gained or lost if the event occurs and adding the products together. Now, this really reminds me of the word average. So expected value is basically the average that's going to be accumulated over a certain amount of time based on the probabilities. So a couple of terms that we need to know. A fair game is one where the expected value is 0. And this is also called breaking even. A fair price, this is the price that is charged to play that will result in a fair game. So the expected value is given by this formula, where A is a net amount. So A is going to equal a prize amount minus a cost to play. And P is a probability that an event occurs. So here we have P sub 1 times A sub 1. So this would be the probability of event 1 occurring times the net amount that is gained or lost if that event 1 occurs. And we want to add it up with all of the probabilities with their corresponding net amounts. So this would be the probability of a second event occurring times the amount that would be won or lost if that second event occurred, all the way up until you get all of the probabilities, P sub n, times all of the amounts, A sub n, that you have listed. Now another word for expected value is something called expectation. So it's just another way of seeing that. And another way you can find it is by taking the fair price and subtracting the cost to play. So if we knew the fair price, we could subtract cost to play and we'd get our expectation. Now the formula for fair price, it's very similar to the expected value formula in that we have our probabilities, all the probabilities, but now we're multiplying by a gross amount. So G is a gross amount. We can also think of this as a prize amount. So we have the probability of event 1 occurring times the gross amount that occurs if event 1 happens, plus the probability of a second event occurring times the gross amount if that second event occurs, all the way until we get to all of the possible events. Now another way you can find fair price in something like a raffle, it would be the total prize money possible divided by the total number of tickets. Okay, so this is how you would find it in a raffle situation. Okay, let's take a look at example 1. It says John is planning on starting a new business selling tie-dye shirts at lunch. Go John. After speaking with many of his friends about this idea, he expects he has a 60% chance of making a $200 profit, a 10% chance of breaking even, and a 30% chance of losing $100. Now, assuming his estimations are correct, how much can John expect to make or lose if he decided to go ahead with his plan? Okay, so this is a sort of business venture way of looking at probability. So these probabilities are just determined. They can be done by market research. Obviously, this guy just went and asked his friends to find his probability. And then the amounts are also associated here. So if we want to find the expected value, we'll just label it EV. What we need to do is take each of the probabilities in the problem, which was 60%, 10%, and 30%, and multiply them by the amounts, the net amounts gained or lost if that event happened. Okay, so we have a 60% chance, and we're going to rewrite that as being 0.6. So you do want to change those to decimals. And we have to say, well, what's the net amount gained with that 60%? Well, there's a $200 profit, and we know that profit is going to be a net amount. Okay, so profit is always going to be a net amount. Okay, so we're just going to put a positive $200. Okay, you get that? It's 60% chance of making $200. We also have a 10% chance of breaking even. So we have to add a 10% chance of breaking even. Well, breaking even means you have a net amount of $0. So I'm just going to put that in there. Notice this doesn't change our expected value because it's still $0. And then we also have a 30% chance of losing $100. So we're going to add a 30% chance of, well, losing $100. So in this case, we're going to make this negative 100. Okay, so some things to note here. All of these probabilities, okay, are all the probabilities listed in the problem. It's the 60%, the 10%, and the 30%. And what do you notice the probabilities adding up to be? Well, 0.6 plus 0.1 plus 0.3 equals 1, or 100%. So when you're doing expected value, always check that the probabilities add up to be 100%. And if we were to calculate this out, we would be left with 90. And it turns out that this is a dollar amount. So the expected value over the long run means we would earn $90 every time we ran this business plan. Okay, so should he go ahead and decide to do his plan? Well, if this is enough profit based on the time and energy and everything else, then he should go ahead and do it. But it looks like this is going to be pretty positive. All right, in our next example, it says Carrie is taking a final exam in which there are 5 possible answers for each multiple choice question. She will get 3 points for each question answered correctly, lose 1 point for an incorrect answer, and gain or lose no points if she leaves the question blank. If Maria guesses on each question and there are 10 questions, what could she expect her score to be? So when analyzing these problems, what I like to do is go ahead and find my amounts first. So she's going to get 3 points here if she answers correctly. She's going to lose 1 point for an incorrect answer, and then gain or lose no points if she leaves the question blank. Okay, so those right there are really our net amounts. So if we're looking at our expected value formula, we have the possibility of earning 3 points. We also have the possibility of losing 1 point. And we also have the possibility of gaining 0 points. Now what I want to do is go ahead and find my probabilities that correspond with each of these amounts. Okay, so the 3 points is if she answers correctly. So what's the probability of answering correctly? Well, that's going to come from right here. So there's 5 possible answers for each multiple choice question, and that means that one of them is right out of the total of 5. And so the probability of getting it right is 1 in 5. We multiply it by its point value of 3. So what's the chance? This one here is for losing a point for guessing incorrectly. So how many incorrect choices are there? Well, there's 4 out of 5. So there's 4 incorrect answers out of 5. And then leaving it blank. Notice there's not really any probability that goes with this, because if you answer the question, you're either going to get it right or wrong. And so this doesn't even factor into our expected value. And notice, even if it did, multiplying by 0 wouldn't do anything. So let's just do a quick check. So the probability of getting it right is 1/5, and we're going to multiply it by its point value. So 3 points for getting it right. And then the probability of missing the question is 4 out of 5, and we lose a point. So 4/5 times -1. And notice here that 1/5 plus 4/5 equals 1, or 100%. So we know all of our probabilities are accounted for, and now we can just go ahead and calculate this. You could also change this to a decimal. 0.2 times 3 plus 0.8 times -1. At any rate, we're going to end up with an expected value of -0.2. Now, does this answer the question? It says if Maria guesses on each question and there are 10 questions, what could she expect her score to be? So notice these probabilities are for each question. So the expected value is to lose -0.2 points per question. So how many does this add up to if there are 10 questions? Well, we have to do -0.2 times the 10 questions, which equals -2. And so her overall score, if she guessed on every possibility, every question, would be a -2. Alright, so it just shows you if you can find the expected value for one question, you can just multiply it by how many questions you answer to get your overall expectation. Alright, number 3 says find the expectation of a raffle in which 100 tickets are sold for $2 each and there is one prize of $50. Okay, so first I want to figure out my prize amounts. And so there's really only one prize for $50. So if we're looking for expected value, we're going to figure out, well, what's the probabilities when we're looking at this? There's only one prize. So what's the probability of winning this prize? Well, the probability is 1 out of 100 tickets. Okay, so 1 out of the 100 tickets that are sold. Now, expected value, you have to deal with net amounts. So how much do you win if you win the prize? Well, some might say you win $50, but remember that you paid $2 for each ticket. So even though you won, you still had to pay $2. So your net amount here is 50 minus 2, and you actually only net $48. Now, that's everything that we see in the problem. But does our probability add up to be 100%? Well, no, it doesn't. So the other option is the probability of losing. So in this case, there are going to be 99 losers out of the 100 tickets. Okay, now how much do you lose if you're a loser? Well, you lose your $2 that you spent. So this becomes -2 right here. Okay, so make sure that your probabilities add up to 100%, so 1 over 100 plus 99 over 100, and that is 100%. Okay, so we could calculate this, so that would be 0.01 times 48 plus 0.99 times -2, and we get an expectation of -1.5, and in this case it is a dollar amount. Now this is going to be per ticket. So for every ticket you purchase, you can expect to lose $1.50 off that ticket. Now of course, in actuality, if you buy one ticket, you're either going to lose your $2 or you're going to win your $50 prize. And that's the allure of the game. But over time, in the long run, let's just say you bought all 100 tickets. Let's see what would happen. So if we took our 100 tickets and we multiply by our expectation of negative 1.5, we would expect to lose $150. Now let's see if that would turn out to be true. So if we bought all 100 tickets, that would cost us $200. So we're already $200 in the hole, and then we're going to win because we bought all the tickets, and we would make $50. And so you can see the expected value would be negative 150 if we bought all 100 tickets. Now, for number 4, it says find the fair price for the raffle in question 3. So there's a couple ways that you can do this. One is by using our fair price formula. And in this case, you multiply the probabilities times the gross amounts won or lost, or just the prizes. So there's a 1 in 100 chance of getting the $50 prize. And then there's also a 99 in 100 chance of getting $0 prizes. And so the fair price that would cause this raffle to break even would end up being 50 cents. Okay, so if every ticket sold for 50 cents, the people putting on the raffle would break even. Now there's another way to think about fair price. We can also think it's going to be the total prizes, right? So the prize money over the number of tickets. So it's basically splitting the prizes between all the tickets. So the prizes add up to be $50, and there were 100 tickets. And notice that gives us a 50-cent fair price. Now, it would have been helpful had I said this was number 3 and this was number 4. A lot of times in raffles, it's easier to find the fair price using this method, and then realize that your expected value is going to be your fair price minus your cost to play. So think about it. If the fair price is 50 cents and it costs $2 to play, okay, so 0.5 minus $2 to play, what are you going to be left with in the end? Well, negative $1.50. And then you can see that this matches our original estimate. So what I prefer doing when you have a raffle is find your fair price first, and then find your expected value second by using fair price minus cost to play, and you get the same answer. All right, for number 5, it's another lottery question, raffle, same thing. So a club's having a lottery. They sell 1,000 lottery tickets for $1 each. There's one $500 winner and two $100 winners. So we have a couple more prizes this time. Now notice I've set this one up to find the fair price of the lottery ticket first, because I always think that's a little bit easier to do. So the fair price is going to be the sum of all the prizes. So there's one $500 winner plus two $100 winners. And then we need to divide this by the number of tickets, which was 1,000. And so we get 700 over 1,000, which is 0.7, or we can think of this as being 70 cents. Okay, so that's probably the easiest way to find the fair price of the ticket. Now, it says find the expected value of one lottery ticket in question number 5. So expected value is going to be the fair price of 70 cents minus the cost to play, which would be the $1 raffle ticket. And so the expected value is negative 0.3. So you're expected to lose 30 cents per ticket. Now it says find the expectation if 5 tickets were purchased. Well, it's just going to be 5 times the negative 0.3. And this turns out to be negative 1.5 or negative $1.50. Now the expected value is just kind of helping you to determine your risk. So you know on average every ticket you buy, you're going to lose 30 cents. So you know this is a losing game going into it. Now it's possible that you could still win $500 or $100, but it's more likely that you're going to lose $1. Okay, so there's no way to come out with this exact expectation unless you purchased all of the tickets. Now, if we want to go back, we could also find fair price another way. It's good to know both of these. So what's the probability of being the one $500 winner? Well, it's 1 out of 1,000 times your $500, and we can use a gross amount. And then what's the probability of being a $100 winner? That's going to be 2 out of 1,000 times 100. And then what's the probability of being a loser? Well, 1,000 minus these 3 winners, which would be 997 chances to lose out of 1,000. And how much do you gain or lose? Well, the gross amount is $0, right? Because you don't win a prize. And if you multiplied this out, you would come up with also that 70 cents right there. If we're looking at expected value, if you like using the formula, you would have a 1 in 1,000 chance of winning, well, not $500 because you paid for the $1 ticket, so this would be $4.99. And then you'd have a 2 in 1,000 chance of winning $99. And then you'd have a 997 in 1,000 chance of losing your dollar. And if you multiplied this out, it would also come out to be your negative 0.3 or 30 cents per ticket. Okay, so I just wanted to show you the different ways. Again, I think finding fair price this way is the easiest, and then finding expected value is the easiest this way, especially when you're dealing with lottery tickets or raffle tickets. Okay, so that is expected value and how we can use probabilities to help us determine a course of action in the long run.